So hi guys, welcome to today's session on split, decide and repeat. So what do you mean by split, decide and repeat? So it is a CART algorithm to construct a decision tree. In the previous session you learnt about the underlying concept of decision trees and their interpretation, and also understood how they help in solving the regression problem that cannot be handled by linear regression. So in this session you will be learning about splitting and homogeneity, impurity measures, best split, regression trees and feature importance in decision trees. So let us start with splitting and homogeneity. Recall the scenario for a doctor asking a series of questions to determine whether a person has heart disease or not. Based on your past experience with other patients, the answer to these questions would finally lead to a prediction depicting whether the person has heart disease or not. Now, if you are a doctor, you would know which questions to ask first, right? When a person might be at the risk of heart disease, the doctor would probably first measure the cholesterol of the person. If it is higher than 300, then the doctor can be pretty sure that the person is at risk. Then he may ask some more questions to confirm his predictions even further. Now suppose instead of measuring the cholesterol, the doctor first asks the age of the person. If the person says 55, the doctor may not be completely sure whether the person has heart disease or not. He or she would need to ask further questions. From both these scenarios, it is easy to infer that to predict the target variable, so in this case heart disease, there are obviously some questions attributes that are more important for its predictions than the others. Cholesterol level is a more significant attribute than age in prediction of heart disease. Why is it that? It is so because for the doctor, it might be evident from past records that people with higher cholesterol levels have a high chance of having heart disease. Say in his or her experience that doctor has seen out of every 100 patients who have cholesterol level higher than 300, 90 had a heart disease while 10 did not. Also say out of 100 patients that the doctor has consulted over the age of 54, 50 of them had a heart disease. Now it is evident that cholesterol would be better to determine heart disease than age. So we basically arrive at this question, given many attributes, how do we decide which rules obtained from the attributes to choose in order to split the data set? So all this question has to come to your mind. So let us start with the discussion. Consider a data set D with homogeneity H. So in decision trees, homogeneity refers to how similar the data points are within a node. The goal is to split the data in a way that each resulting node contains the data points that are as pure or homogeneous as possible. So if a data set has high homogeneity, it means it has only one single class. If a data set has low homogeneity, it means it is a mixed class. So for classification purpose, a data set is completely homogeneous if it contains only single class label. For regression purpose, a data set is completely homogeneous if its variance is as small as possible. Let's consider data set D with homogeneity H and a defined threshold value 70%. When homogeneity exceeds the threshold value, you need to stop splitting the node and assign the prediction to it. As this node does not need further splitting, it becomes the leaf node. Suppose that you keep the threshold value as 70%. The homogeneity of the node in this illustration is 80%. It means that the homogeneity is greater than the threshold value, hence no splitting is required and this node becomes a leaf node. But what do you do when homogeneity is less than threshold value? In such a case, till the homogeneity H is less than the threshold, you need to continue splitting the node. Now how do you handle best split for different attributes in a decision tree using CART algorithm? If an attribute is nominal categorical, then there are
2 to the power k minus 1 minus 1.
If the attribute is ordinal categorical or continuous, then there are n minus 1 splits. Now what is discretization? So discretization is a process of converting continuous data into discrete data. So why discretization is important in decision tree? Because continuous variables have infinite possible values, making splitting complex. Discretization simplifies this by grouping values in bins or ranges. Now, what do you mean by impurity measures? So in decision trees, impurity measures are used to evaluate how mixed or impure a node is in terms of class labels. The goal is to split the data in a way that reduces impurity, leading to more homogeneous child node or leaf node. Why impurity matters? A node is impure if it contains sample from multiple classes. So there are three types of common impurity measures. First one is classification error. The second one is Gini impurity. The third one is entropy. So let us discuss all these entropy measures one by one. Classification error measures the fraction of incorrect predictions. So error equals 1 minus max of pi. It is less sensitive than entropy or Gini. Second is Gini Index. It measures the probability of misclassification.
So Gini Index is the degree of randomly chosen data points being classified incorrectly. So Gini Index can be written as summation of pi into 1 minus pi, where p is the probability of the class and I is the class label. So Gini Index of 0 means all the data points belong to a single class. And if the Gini Index is 0.5, then the data points are equally distributed among different classes. So suppose you have two different classes of data points. If the data is completely homogeneous, it means that the data points will belong to only class 1 or class label 1. Then the probability of finding the data points which is related to class 0 will be 0. It means that P1 is equal to 1 and P0 is equal to 0. So if you calculate Gini index in this case, so summation Pi into 1 minus Pi will be 0. It means that if the data point is completely homogeneous, the value of Gini index will be 0, or in this case the lowest. Now let's move to entropy. So entropy quantifies the degree of disorderness in the data. The value of entropy ranges from 0 to 1. So when entropy is 0, it means data point is very less disordered or homogeneous. So higher the homogeneity, lower is the entropy. Similar to what Gini index is. But its value ranges from 0 to 1, and for Gini index the value ranges from 0 to 0.5. So now you must be clear about what entropy is, what classification error is, what Gini impurity is. So these factors are building blocks of decision trees. I mean, with these factors the decision tree can be constructed, or with these factors you can split the data set accordingly. So this is what the use. So now what makes the data the best split? There will be a decrease in impurity from some data points when split is occurring. So there is some data points and now we want to split this data. So based on some attribute, the split has to be done. Decision factor of splitting this attribute will be based on how much impurity is going to be reduced on that split. So this is what the concept is. So we will define a term called delta impurity. It means the difference of impurity pre-split and post-split. So if this difference is maximum, then we will have a best split. This means that you are reducing the impurity to max. It means you are making the data set more and more homogeneous. This is how homogeneity and impurity is related to each other. So gain will be entropy initial minus entropy when there is a split on attribute A. So gain is equal to D minus dA. So you must note that reduction in entropy equals the information gain. So you always wanted to increase the homogeneity of the resultant node. Okay. So in case of classification problem, we always have to go for reducing the impurity of the leaf node, or in other words, maximize the purity gain. So now after understanding this concept of entropy, you can easily define which feature will be important and which feature will be less important. So the data set or the attribute on which the split where impurity gain is maximum, that feature will be important. So on that feature split has to be done. So in previous case where doctor checks the patient with the cholesterol level and the age, the cholesterol level is the important attribute with respect to age. So you have to decrease the entropy to a maximum level so that feature on which the splitting is done is treated as the important variable. So this is all about what is classification error, what is Gini impurity, what is entropy, how to calculate the important feature in a data set on which split has to be done. Okay, so all these things are related to one another, and Reading this topic again and again will fetch every information in your mind. So keep studying, keep watching the video. Thank you.